Hey everyone, we're going to be looking at this question today. So let's look at what we have here. We have an electron that is going to be entering the region between two parallel plates. And we're given that the initial velocity is 4 times 10 to the 6 meters per second. We know that the field is 175 volts per meter. And we're asked to find the distance that the electron comes to a stop at. Because we're talking about an electron, we want to make sure that we write down our charge as well as our mass. So let's make a plan to find D. Well, we know that the initial velocity is VI equals 4 times 10 to the 6 meters per second. We know that it comes to a stop, which is 0 meters per second. So because there's a change in velocity, we know there's an acceleration. So we're going to look at our formulas for acceleration that we used a lot in Physics 20. So because we have VI, VF, we need to find A as well as D. The one that comes to mind is VF squared equals VI squared plus 2AD. However, to find D, we still need A. So let's look at a way to find A. Remember that because we have a change in momentum, we know that there is a force acting on that electron. Therefore, the net force, F equals ma, is actually the electric force, and we can determine the electric force from the equation E equals F over Q, or in other words, F equals EQ. This means that we can solve for A and in turn solve for D. So let's start with our force equation, F equals ma. We know that this is going to equal our field times our charge. And solving for A, we get A equals EQ over M. So let's fill in the values we know. We know that we have 175 volts per meter, the charge is 1.60 times 10 to the 19 coulombs, and that the mass is 9.11 times 10 to the minus 31 kilograms. Plugging this all into the calculator, we get 3.07354 times 10 to the 13 meters per second squared. So now that we have our acceleration, we can go back to our other equation, VF squared equals VI squared plus 2AD, and solve for D. So let's isolate the D by subtracting VI squared from both sides. That gives us VF squared minus VI squared equals 2AD. We're going to divide both sides by 2a, and that's going to leave us with D equals VF squared minus VI squared divided by 2a. So solving for D, filling in everything we know VF squared is 0, that VI squared is 4 times 10 to the 6 meters per second, and that we're going to divide by 2 times the acceleration that we calculated from the previous step. Remember to carry more than a couple decimal places. We don't want rounding errors. And putting all that into the calculator, we get that the distance is 0.260 meters, or in centimeters we get 26 centimeters.